Hello. Hello, everyone. We are about to start. This is Qingwu. Service Army Mohammed Bogdaya. Actually, we are chair of the auto working group, and welcome to auto session. Welcome to London. So this note will apply. So probably you can read this. And the code of conduct. Please be nice to the colleague in the room. Administrator, actually, we make sure you wear a mask if you want to. You don't speak. And so this agenda for today's discussion, a pretty tight agenda, and so we will focus on charter item, auto. Turn on the mic. Okay. So the focus agenda will focus on charter item and auto deployment update. And if we have time, we will go through the non-charter item. This could be good input to the auto charter. Document update. So we have two new RFC get published since the last IETF meeting. One is path vector, the second is course mode. We still have a performance metric in RFCQ at dependency to the TCPM working group draft. And for working group draft, we have in the auto working group, we have auto OM. This will be presented in today's meeting. The second is auto new transport. Based on the discussion in last IETF meeting, we consider to split it into 4 components. So we will give the update for where we are, how we can move forward. The milestone has no change, but I just want to remind for the first auto new transport, we already lag behind. And socialized auto, this as usual, actually, we continue to do this dissemination effort. Actually, we already built the auto tutorial, and this has been discussed in last IETF meeting. And also, we have some auto integration effort that has been promoted in MOps and integrated with CERN, RH, CON, Ethernet. And we also have a paper to discuss the auto tutorial. Working group status has been submitted to the Internet Protocol Journal. And so you can see we have more visibility to the auto software package. And we continue to do this IETF hackathon and demonstrate in the happy hour. And we also will have actually continue effort for auto deployment with 1040 auto deployment and integrated auto with CERN. So for this, any comments? If not, let's move on and go to the first presentation, auto new transport. So Roland.
So can you hear me? You will share the slides?
Yeah,
okay.
Share your slide.
It's about Alto Transport, still struggling with how to implement, let's say, Alto also for HTTP2 and HTTP3. And we had this Alto version, new version 03, and this includes still some information regarding the classical, but also regarding the pull mechanism and the feedback that we've got. And therefore, I will also start on the first slide with it to, in a way, put a separate document regarding this and yeah, split, let's say, the current document into 2 documents, additional documents. Next slide, please. I just wanted to recap a little bit what we had discussed so far and where the position is and the feedback we got so far. And next slide, please. I have a couple of more slides. And we got also feedback from HTTP experts, Martin Thompson, Spencer Dawkins, Mark Nottingham, and Martin Duke, and we more or less put it in. And the idea to split the document into separate parts is also some yeah, results of the feedback we've got. Next slide, please. Also, just to remember, so there was a discussion in IETF 114 regarding the client pull and long pull mechanism. We saw that HTTP 1.x, which is related on strict sequence numbering, and you can, as you can see on the right-hand side, this makes it a little bit inflexible regarding the server push, and the idea is now to describe the push promise mechanism, let's say separately in a separate document. So we need to split a little bit. The idea is to have one draft that is talking about the general issues, and then anyway have additional draft where we describe the push mechanism, and I have also a slide later that describes, we might also be that we will discuss the server put. But at the moment, this is out of scope. We are not focusing so much on this. Can you move to the next slide? As you can see here on the right-hand side, which a little bit shows also the problem. So when you look to the on the right-hand side above, we need to have a strict, if you have a transport also the queue mechanism, we rely on strict sequencing of the number and strict scheduling. And this is a little bit inefficient. And when the idea is that server can also push multiple information, so that we yeah, get advantage of the features that HTTP2 and HTTP3 have. That is the basic idea, and that was also discussed in the last IETF meeting. Yeah, so discussion must go on. Can you move on, please? There was also discussion last time regarding here the HTTP2 control knobs, and was discussion that QUIC or HTTP3 is a little bit different. This, and the idea is it's now to in a way re-specify or discuss these operations and to remove them. And yeah, that is also something that we discussed so far, and I think the idea is then accepted. The style guide things, I just want to go over it. We can skip this slide. I have not. And now we come to the major changes and the ideas that we have, and where we need also the feedback from this group regarding the idea, as I state. So the major structure of the transport document, the idea is to change this, to split the current document into separate documents. At the moment, the idea is to have 3 documents. The first document specifies the common model, so supporting of the incremental updates queue, and is valid, let's say, for all HTTP connections. And now we made a proposal for a second document, and this is especially looking on the focus on the client pull and long pull mechanisms. And if we agree here in this group at the moment, they're part of the first document, we have prepared, let's say, a draft version, and if the working group accepted it, we will move these sections to a separate draft. And yeah, and let's say what is already on the table, or what we have presented so far and already uploaded, is the server push mechanism. But in our internal discussion regarding the move of the, let's say, the pull section into a separate document, we are also very verify in this discussion. So in the sense, the idea is then to have multiple documents, one describing, let's say, the overall mechanism, and then the various mechanisms of HTTP, let's say GET, or a mechanism will then also described, let's say, in a separate document, and uh, uh, the client pull and push. And if we also want to describe the put mechanism, we will need to do this in a separate document. At the moment, we have no clear idea regarding this and how to handle this. Yeah, and then we can move to the next slide pretty fast here. We can see it here, visualize the structures, the idea that we had. We had in the document one this, let's say, increment queue updates, create, read, etc. Then we need to decide whether we want to put this out of the first document and describe the long pull mechanism in a separate document. This is something that's at the moment officially included in the current transport document. We need to decide to put this out. Then there is a new proposal regarding the push and the client, which is related especially to HTTP2 and HTTP3. So this will be then some kind of version specific document. And at the moment, out of scope is the server put, but that could be also a document for, yeah, let's say discussion, further discussions. Then, okay, here there's a short recapitulation of what is based in the document one. Document one, for example, we have the definition of, let's say, the transport of information, and the incremental updates are described there. The Alto server is a master of the updates. We have this, as mentioned before, the CDR operations. We are related, let's say, when we're using this document to a strict sequencing, and only the Alto server can write to it, and client can issue commands sequentially or in parallel. So that is the basic stuff that we have discussed so far. Yeah, the sequence number is, let's say, up to 64 bits as described here. And so the structure is pretty similar to what we have discussed so far. Then let's move to the next slide, the proposal for the pull document and client read updates. Very simple design. It's then only the get mode method that is used here, and could be used also for caching and content distribution in large scale. And server client supports then also long pull support and transfer scheduling, and the pull design allows the client to issue concurrent pull requests, and this optimizes the whole design there. And transfer processing and requirements, yeah, they are specified more or less as described, and we specify HTTP transport control, yeah, here, but this more or less and also transparent to the Alto design. Next slide, please. So the server push, that is something that is here a little bit new or different. Since HTTP 2 and 3 both use push promise mechanism, and this is a main advantage. The idea is to put here a separate document, and this would also be then from the transfer perspective, then also, let's say, one additional advantage. And the idea is here to specify this mechanism, which was also in an early stage defined in the original draft, was included to bring this out and have then there, let's say, a separate document that is then valid or can be used for this mechanism. And that is more or less what the current proposal is so far.
I don't know if Martin, if you want to read the question right now or Martin Duke. So are doc2 and doc3 completely independent mechanisms to do the same thing, or do they depend on each other?
I don't know if we can say it's really doing the same thing, or do the same thing a little bit differently. So the push promise mechanism that is described only in let's say in the separate document and valid for 2 and 3. And let's say the basic document gives, let's say, more or less the general overview and structure of all the concept. Yeah, that's what I say. That was the idea.
So, like, unless are there? I would
Martin,
really like
can
us
you
to have.
I'm sorry.
Richard, do you want to comment too? You're also
Yeah,
yeah.
hey, Martin, sorry to jump in. I should have waited after you, but I'm trying to answer your question. The dependency is 2 and 3 are independent. They both depend on 1.
Yeah. I'm strongly disinclined to publish 2 different solutions to this problem.
Okay.
If like, unless this like clearly, unless they address different use cases where, like, you know, use case A, like 2 is much better because of these certain metrics, and like for use case B, doc3 is much better. And like that would have to be pretty strongly motivated. I think we already have one solution to this, which is SSE. Is it your opinion that one or both of these is way better than SSE?
SSE has much larger overhead. In terms, actually quite complex, and actually 2 and 3 are way simpler. I think essentially 3 essentially is a complete replacement of SSE using a much more modern design. Of course, if you really push SSE, for example, and really, for example, eventually it's really built, like you said, and it should be built on top of independent. If it's still built on top of HTTP 3, for example, then actually you can gain performance over SSE, because SSE is still fundamentally underlying, supposedly it's a single using essential total serialization. So therefore, you need to serialize everything. But here actually you can even have concurrency. Even you can push all updates concurrently. So therefore you can gain latency. In the worst case, you have large number of subscriptions and you want to push all updates. Doc3 would even completely beat the performance of SSE.
Great. All right, that's what I thought.
Yeah.
So my understanding is that push is not much beloved by the HTTP community,
right.
and maybe not supported that well. So without having any data whatsoever, I would be inclined towards the doc2's approach rather than doc3 approach. But you know, if you guys have the data, like 3 better, that's great. I would actually, I mean, we're on the problem space of like server updates, right?
Sure.
In a perfect world, we would have either doc2, I mean, whether you want to combine 1 and 2, like I'm not gonna, like fear, you know, I haven't looked at it editorially if that works or not, but I would certainly like to do either 2 or 3. And in a perfect world, consider like obsoleting SSE. Like in an ideal world, like, I mean, you could certainly give me a reason why that would be a bad idea, but I think having 3 solutions to this problem is way too much for Alto. Thanks.
I think personally, I would agree with you. I would say, yeah. So I think actually, yeah, doc2 really is a cleanest. So Martin, sorry. So you want? Let me clarify. So you want either 2 or 3? Of course, SSE already there. And are you saying that we should pick either 2 or 3 or both, or you say, or you're neutral, or you prefer that we pick 1 of 2 or 1 of 3? Just clarify.
All right, yeah. So there are 3 solutions. SSE is solution 1, right?
Yes.
So okay. So someone, I do want to say that if someone can make a convincing case that that these things address different requirements in different use cases, like that's an argument. That's a discussion we can have. But failing that, I would certainly want to down select between 2 and 3, doc2 and doc3. And again, I don't have the data, but from what I know, I would be prejudiced towards doc2 because it doesn't use push. And then like as whether doc1 is merged with doc2 or 3 is an editorial thing. I don't, you know, whichever. And then I would certainly encourage the working group to look at obsoleting SSC. And I don't have the implementation wiki like in front of me right now on how installed that is in the base. I seem to recall it was not very out there, not deployed much.
Correct.
Okay, so if it's not deployed and implemented much, then like all the more reason to just get rid of it if we think this is way superior. I mean, this is not such a widely deployed protocol that we can't make really sensible revisions to it, I would say. But that's the second issue. I think the first thing is to down select of all this stuff, figure out what to do here, and then we can have a discussion about obsoleting other documents.
Okay, so how do you propose that we proceed? So we're going to re-listen, because right now, by the way, very quickly at high level is you can emulate 2, actually you can emulate 3 using 2. Of course, then assumption is you should, there's some mechanism even to emulate 3 using 2. Basically, you allow the client to essentially prefetch, essentially put a large number of pending put, because essentially is a server push can reduce latency even below a single 1 round trip time. And pull, you really conceptually, if you don't want to really have a lot of pending requests, you can have a large number of pending pull requests put on the server. So therefore, you put a load on the server. But if you think like, for example, in implementation, we think, for example, overhead on the server side may not be a major problem. We can essentially ask a client to really send out a larger number of pending pull requests on future sequence numbers to emulate essentially even like document 3. Of course, that would at some price of higher, slightly more complexity at the server side. But maybe if that's price we can pay, then clearly a document 2 will be simpler, and we can proceed from that way.
So I don't have a strong opinion on this except what I already said. Like, I mean, you guys have been looking at this problem closely. I'm sure you guys can come to a smart decision about this. The other thing I will say about 2 versus 3 is that if we pick 3, then I think we have to keep SSE because we need an HTTP1 solution, if I'm not mistaken.
I see.
And that's okay, like, I guess. But yeah, I mean, I would look at it and like, I mean, other people in the work group have an opinion, of course. I certainly with my AD hat on, I don't really care what you pick. As an individual, I'm a little biased towards doc2, but you guys have way more information about this than I do. Thanks.
Thank you.
Just one additional kind of on this part. I think what will be really useful for the working group is that the rationale about I would say the need for these 3 functionalities are really documented so that we understand what are the scope of the problem, and then if there's overlapping to justify and motivate why we need a further solution rather than just pick one of them. If we have this material, I would say clearly formulated somehow, that will be really good for the working group to know. And exactly that this can be included in the current draft you have without proceeding with any merge or any split. Just explain this. These are the 3 problems we are trying to solve. These are the approaches, and we will pick or select all of them based on the information you will receive. That will be really good to have in the next version of the draft.
Understood. Yeah. Okay.
Okay.
Then could you go? I think the server put was for further study, let's say, and I think that's also pretty much the end of the presentation. Could you check, Jin? Next steps. Okay, understood. We already more or less talked about. Describes the rationale, motivation, use cases exactly, but also not to have too many documents. It's also understood. So I'm through then to the presentation. Any other question or someone in the queue or no?
Just one comment about the I would say more logistical aspects. As you know, we are out of schedule from this milestone for this one. We are supposed to deliver something in the late September. I don't know if you have a plan for or at least the expected scheduling for delivering, I would say, the pieces we have so far. Do you expect to have something, I would say, in the next 3 months, have something which is stable, or?
So what we discuss in the group, I think we can do, because at the moment it's a split of what we already had.
Yeah.
And with the motivation to say, okay, let's describe the reasoning, why it is splitted, and discuss this on the list. I think that would be a good progress. And I won't think that there needs to be so much change regarding also the content or how it works in the draft. I think that is pretty much described. We got feedback regarding what's not working. Some of the feedback is not analyzed and discussed so far. We will do this, but in, I would say, 3 months could be or feasible thing. Yeah,
that's fine. Thank you.
Okay.
Thank you, Roland. Yeah.
Then, if no other questions, thanks to.
Okay, let's move to the next presentation, Auto OM. Jason. The floor is yours.
Hello, everyone.
Yeah, we can hear you.
Okay, thank you. Yeah, so yeah, very sorry I cannot attend the IETF meeting in person. So, but I will remotely present the update about the OM documents. So next page. Yeah, this is a quick status after the new versions to the trackers, and also the in the GitHub actually have some quick fix because we have the syntax errors on the young models, and we do fix it on the GitHub that have and upload to the trackers. We'll do that very soon after the IETF meeting. So next page. And for the new revision, the main changes to resolve the 3 open discussions we have in the mailing list since the IETF 114, and there's a list about some discussion on mailing list pages, and some post solutions on the documents, and also a quick update about in the IETF 115 hackathon. So we have partially implemented the OM data model in our open auto implementations, and it can be checked in the GitHub. Yeah. So next page. Here is a very quick overall update because we reorganized the table of content. We reorganize the sections and subsections to exactly align with all the 7 basic requirements we identified in the section 4, and we also put some implementation specific data models as examples in the appendix. Yeah. So next page. Yeah, from this we will discuss some details about how we make the progress on the 3 open discussion topics. And for the topic 1, so it's about how to handle the data sets in the auto-related data INI registries. And the current decision is to use the identity to define the data type. This can allow the data to be managed in more modular way, and it can guarantee some backward compatibility, and the future documents can define the new types by adding the new identities in some extension modules. So here's an example. For example, we have the performance metric document. So in the future, we can have the performance metric modules, and once the related document become the standard, the YAML module will also be the standard, and can be applied by the other servers. And in that page, but about the whether to use the IANA maintained modules, the working group has a different opinion. So some people will support this because the IANA maintained modules can guarantee the compatibilities, but someone may have a different means. And because if the node effects have the frequent changes, so the IANA maintained modules system cannot be overdone. But the example I want to explain So if we use the unmaintained modules, what will look like? Matt has a comment.
Yeah, I have only one comment about the what you have mentioned about the non-support for the IANA maintained model. This actually defeats the idea of having an IANA registry for the protocol. So if you are not expecting to have something which is extensible and new values defined in the future, then what these same arguments can be against having this IANA maintained model. So I don't think that this is really an argument to take into account. The key one is that if you want to have something which is really, I would say, open to new implementation without having, I would say, heavy changes in the process, the IANA maintained model are there for free. And new entry, once it will be added to the registry, the model will be automatically generated, and there is no cost there. But the other one, so I'm not sure I understand the other argument. If you can just elaborate a little bit, that would be really great.
Yeah, so you're supposed to use the element in modules, right? Yeah, actually, I agree with you. So in the example issue, the how the element in modules will work. So the next page will, if we go to the next page, so you can see once the experimental modules become the standard, it will update the modules. But because the basic module depends on the other module, we don't need to update the basic module. So only the other module will be updated. So that's I think that's a main benefit. But we'll let the we will see what's the comment from the working group. Yeah, so next page. And that's a major part. We have a lot of discussion on mailing list. So to achieve the server-to-server communication, we identify the OM may need to have the following three parts of the configuration. So one is we need to configure how the server to be discovered by another server or client. And this part is already included in the latest revision. And we will provide the new grouping of the auto server discovery grouping, and it can have the different kind of the manners. So far we have three predefined cases for the server discovery. We learn from some tactical deployments, like the reverse DNS, using the IR and DB, but in the future it can also be extended through the augmentation. And next page. And the second part, actually, we also need to configure how the server to discover another server. So that part is still in the progress. And we have the current proposal. We will have another grouping, and this grouping will include the configuration about some parameters, how the server can be used to discover another server. Like for the reverse DNS, you need to configure the DNS servers, and yeah. But so this model can also be extended by augmentation. But now the sad part is that we can decide for this grouping which part should be put. We can put it to the basic auto server instance, and another option is that actually we can also put it into a separate containers, like we have the client container, because we think this part should be more like the configuration parameter for the client, not the server. So actually, next page we will discuss some options for this. Yeah. So so this will also involve the start of the configuration parameters. So we need to configure how the server to communicate to discovered servers. So that part is not determined whether it should be included in this document, because we have the multiple potential solutions to handle this. We have had some discussions on the mailing list in the previous IETF meetings, and we have some individual drafts to talk about this. But to a very quick summary, so this can be the three kind of the solutions. We can use the server client mode using the auto protocol, or the server client mode but using some different underlay protocols, and also can use some peering mode to do the server-to-server communication. But there's a thing that none of them has become the standard yet. So actually, in the next talk, in the implementation and deployment updates, we will have some discussion about more details about what we observed, how to solve this. But in this talk, so far, the very quick observation that I think if we consider use the first solution, is the client server mode to using the auto protocol to do the server communication. So that can be the simplest approach to leverage the existing auto standards. And to support this, the OAM can extend to, because so far the OAM module only have the auto server instance, but to support the server communication using auto, so we may have a single auto server instance, but have the multiple auto client instance. And for the auto client, you can configure how to do the server recovery, use the previous grouping. Yeah, so the next page. And the third part, which is the main part, is about how to handle the information, how to configure the information resource creation. And that's a major part of this OM model. And it's assisted by the FC 7285. So there are two major components. One is the data source, another is the algorithm. So for the algorithm, we need to configure how to use the data. And for the data source, is to configure how to get the data. But and for the OAM data model, what we need to do is to provide the basic unified model to cover all the common configuration cases and the configuration parameters. So next page will give some envision about this. But from our practice and experiments, so consider the OAM, and there'll be some slightly different from consider the implementation and the deployment. From the implementation and deployment specific, what we need to progress is how to handle the heterogeneous format of the data sources and how to process the data collected from the data sources. But for the OAM, actually more interested in how to handle the heterogeneous mechanism to access the data source, and how to correctly configure the calling flow for the information resource creation. So in the OAM data model, so we separate the information resource creation to three part of the data model: the message layer, the algorithm layer, and the data source layer. And for the next page will be a concrete example. Yeah, that's what the current OAM data model do for the message layer. So when you configure the common information resource configuration, for example, the resource ID, the resource type, the URI, probabilities, and which algorithm should be used to create the information resource. And for the algorithm, need to configure the which data sources you will use to generate this information resource. And also have some implementation specific parameters. Like for the network map, may need to configure the PID granularity, and for the cost map. You need to configure the precision to compute the cost. And for the data sources, it will include some parameters about like the source bound protocols and the update mechanism, and also the major part we learned from our practice is the complex resolution. So the next will do this. Yeah. So that will be a major lessons we learned from the real implementation. So the different data sources may have the conflict. So the different data sources can have the different wires for the same entries. So we need to actually resolve it. Martin, have questions?
Jason, are you ready to take question? I think
Sure.
you probably need to wrap up for this.
Sure. Actually, that's the last topic. Yeah.
Okay, Martin, do you want to? No.
No, you're
Okay.
Martin Duke, I'm concerned that, so my comment in 114 was that I thought we were going a little bit beyond Alto configuration to things that are not Alto, which to me is out of scope. Like data collection is not part of Alto. And this T3 item seems to be trying to configure something that is not Alto. With T2, I could be corrected on this, but like there's no server-to-server communication RFC in Alto, correct?
Yeah. I mean, T2.3. Yeah.
So, right. So, but there's no server-to-server discovery. There's no server-to-server communication spec in Alto. Like client discovery of servers is in scope. So 2.1, that's fine. I'm concerned that the other two are something that is not Alto that we're trying to configure in this document, which to me is out of scope. Do I misunderstand what's happening here?
Yeah, that's correct. So that's a question to the working group.
Okay. Well, if that is correct, I would, you know, you're welcome to like take this other. Don't throw the work away. You can put it in a different draft or publish it some other way or whatever. But I would like this draft to actually focus on configuring the Alto protocol as defined in the RFCs that this working group has published, and not speculate about other stuff that this working group has not published. Thanks.
Okay. Yeah, that's understand. Yeah.
So, Jason, so I agree with Martin. Actually, the one way forward, as we discussed offline, actually you can take into the appendix, to discuss this, give an example, or we can completely split out, yeah, for this.
Okay. Okay, that's the last page actually. About yeah, maybe go through the previous page.
Yeah, well, maybe we already run out of time. Then maybe let's move on to the next presentation. So next one is about the auto deployment update. So Jody, Kai can, and Rachel can, and also Luis can share your update.
Yeah, so Jody Ross from Qualcomm. Yeah, I'll talk about deployments, but this is a collective effort, so I'm going to hand it over to
Just
Kai.
one quick question. Sorry to interrupt. I think this is we probably have a version 3 slides. I think this is the older version.
Thank you for a reminder. Then
Thanks,
check
Kai.
whether we get it. Do you get the latest one? Yeah, maybe we can give floor to the Luis and so who can upload? Already upload.
Yes, you need to upload the version instead of coming back.
Okay.
Can you just proceed with uploading the new version, and then so that we can show them. In the meantime, Luis can present his.
Yeah, let's change the order. Let Luis to present his first. So Jody can have to upload.
So hello everybody, I will present the update of the deployment of, or the integration of Alto in Telefónica, so in such a way that we can expose the Telefónica network information to the Telefónica CDN. So it's a single domain environment, single administrative domain environment, but we will comment across the presentation that also has some influence in other domains, for users in other domains in other operators at the end. So this is an update from last IETF. So next slide, please. Just a quick reminder, so the objective of all of this effort, all of this work is to improve the delivery of traffic from the Telefónica CDN in the internal of the network. So such a way that the decisions that the Telefónica CDN, the logic of the CDN could take, could consider also the network information, the topological information. By now, we are playing with the number of hops. The idea is to include more powerful, more rich metrics in the future, like could be maybe the occupancy of the links or the latency and so. By now, it's just simply the number of hops or the IGP metric you wish. So the project was already presented in last IETF, in Alto for sure, but also in media operations. And so I will provide an update here. Next, please. Well, let me also comment that this was already presented in this IETF2 media operations on Monday. So this is just, I know that you are very familiar with that. So what we are playing, the pieces that we are playing is the network map, which essentially groups the different prefixes representing the endpoints. In this case, the endpoints will be, on one hand, the prefixes allocated for the end users, for the consumers of the streaming content. On the other hand, the other endpoints, let's say, would be the caches, the IP addresses of the caches for delivering the content. Then with that, we are able of building the cost map and obtaining the relationship in number of a given metric between the CDN caches and the end users. So then we have the overall topological view for understanding the hops, the metrics, and so between both endpoints. Just to remark, the network map is obtained through BGP. So we establish a number of sessions, so BGP sessions with root reflectors in charge of exposing or the advertising the prefixes of the end users. And on the other hand, for the cost map, we establish BGP LS sessions with different root reflectors. So in a manner that we can build the topological relationship between the nodes connecting both endpoints in each side. Okay. So next, please. So this slide summarizes the process as follows. Last IETF, I presented the initial part. So we started playing with a toy environment in the lab just for validating the concept. Then we moved to the pre-production lab of one of the operations of Telefónica. So now starting playing with more realistic environments, different vendors, and understanding somehow the issues that the real architecture could bring into the deployment. For instance, in the lab, we were playing simply with OSPF. In the pre-production lab, we start playing with ISIS, and this produced or this motivated some changes in the Alto, and so on so far. So the point where we are now is we ran a pilot last month on October 27th. in the real production network of Telefonica in this operation in Spain. So the time in the gap between IETF114 and IETF115, we essentially prepare all the environments, so deploying Alto, connecting Alto to the different road reflectors, doing the field works of server installation, all the security aspects for hardening the deployment in a real network, so trying to be sure that the flows between the route reflectors and the Alto server goes, I mean, where they should go, etc., etc. So what I will comment is the result of this POC, this pilot. So it's yet a work in progress, but I will provide you some information in this respect. So next, please. Yeah, an initial known restriction that we have, because some dependencies on the real network. This graph represents a kind of topological hierarchy in which we structure the networks in Telefonica. More or less, all of them follow this kind of schema. So we have different levels, different hierarchical levels, being the hierarchical level 1, the one for interconnection, so connecting to other operators, being the hierarchical level 5, the one representing the cell-side routers and so. In the middle, we have the different levels, aggregation, regional, and so on so far. So we have a restriction between the connections from hierarchical level 2 to hierarchical level 3. The problem that we have is for a specific vendor, we have an issue with the software, and we cannot include the proper information in OSPF. So a hierarchical level 2 with hierarchical level 3 is connected through OSPF in this case. So not in all the footprint of this network, we have solved yet this issue of being able to retrieve the information later on with BGPLS. So there is a gap in this respect. So we have a small area, a small region of the country being solved, but not for the general country. So this is known in advance, and well, this will take yet time to be solved because we need to wait to the new software release and so on and so far. Next, please. So good news or bright news about the deployment. So we connected the Alto server with the BGP speaker to the route reflectors, and we start to retrieve a number of summarized IP address ranges, so more than 16,000 of them. And these ranges corresponds to different kind of users, fixed users, mobile users, and enterprise users. This is good because we can then start differentiating the kind of flows that we can deliver from the CDN to the different users at the end, according to the type of user that we could, the user that is requesting the content. Those IP ranges are both internal and external. So the majority of them for sure are internal, but there are also some external. What are those external IP prefixes? Are those corresponding to the national interconnections? So the ones that we are getting for the peering points. Why the national and not the international? Well, all the international connectivity in Telefonica is handled by a specific carrier, from a tier 1 carrier for the Telefonica group. So the only nodes that deal with interconnection in this operation are the ones for the national interconnection. Why this is relevant? This is relevant because we also can improve the delivery of towards the users that are coming from other operators. Taking note that the CDN is delivering for live streaming is delivering OTT traffic, right? So sports and this kind of thing. So it's also important for us to have to understand what could be the better cache to serve external users. So trying to identify also the proper interconnection point. Also, as good news, we were available to build the cost map and reflecting in this cost map the IGP metric. I will show you an example later on. And then also interesting, the load of the server that is hosting the Alto server is not significant, so it seems to be work pretty well. So note that I commented before that we cannot build all the cost map, but we retrieve the information. So we don't expect higher load because of the fact that we could resolve that point for the cost map. So the load should be the one that we have now, more or less. And this is not important. Next slide, please.
Do you want to take a question right now or wait till the end of your presentation?
Let's wait for that. Okay. Let's wait for that. So next, please. This is just an example of the information retrieved. So you can see there the actual PIDs without the actual IP address ranges from Telefonica, and also the cost map with the relationship of the IGP metrics among them. Interesting to note, I will just highlight one point that I will comment at the end. You see there in the PIDs on asterisks, and this is because of the fact that realizing, I mean, running the POC, we realized that this information, the identifier of the PID is something sensible. So this is why somehow we put here this kind of simple obfuscation, but I will elaborate a little bit more at the end about this as a potential topic to address as well. Well, that were the good news. The not so good news, or the things that we need to yet fix, is there is no information of IP ranges about the 5% of the POPs, of the point on presence. So we need to analyze what particularities are on these POPs to understand why they are not advertising the information. Some of the IP ranges seems not to be retrieved. So we have a good number of them, but there are some missing. So we need to understand what is happening with them. Probably we need to connect to some further rock reflector to understand, I don't know, to look for where these prefixes are being advertised. Only 27 PIDs are both in the network map and in the cost map. This could be the result of the known issue with the interconnection between hierarchical level 2 and 3, but we need to assess that. We are not yet sure if this is the cause. And finally, the PIDs for the CDN nodes are not yet captured, and this could be just a matter of connecting again to a different root reflector. This operation in Telefonica has a number of root reflectors for different purposes, so it could be the case that we are missing some relevant connection, some relevant session BGP for this. So next steps, not taking much more time. For the pilot, we need to understand how to consume the ALTO information. Okay, we now have the ALTO information, but how we should consume it. So how often we can retrieve the map and so. So we need to continue analyzing the information received to understand the dynamics in a production network. So there will be changes, there will be situations. So we need to understand how it works in a real stuff. For sure, we need to debug issues, and also we need to wait until the resolution of the operating system of this particular vendor just to build the overall map in the network. For the ALTO-based solutions, next steps will be the productification of ALTO. So make ALTO a product for logins, for log registering, for all the events that we could monitor and so on and so far. And also to work on how to automatically upload the topology. So for instance, one of the questions that are rising to us is what happens if in some point in time, the topology that is uploaded is quite different from the existing topology. What should we do to consider the new one, to consider the old one, to discard the new one? So these kind of things is something that we need to learn yet and provide. And then finally, for ALTO or the Media Operations Working Group, the idea would be to document the pilot. So, and probably this could be also interesting for MOPs, to identify the gaps, issues, and the improvements in the solutions that could be worth it to work. And in this respect, I would like to emphasize the point of the security, the obfuscation of the PIDs, and so probably other security capabilities in the ALTO environment. And yeah, for sure, to provide another update for next IETF, and hopefully with all of this solved, and let's see if we are able to do so. So there is a question.
Thank you, Luis, for your presentation. My name is Ayoub Messous. I'm from Fujitsu Research of Europe. I found this presentation very, very interesting. Can you go back, please, to the hierarchical scheme that you showed for different layers? So I'm very interested in this topological IP transport hierarchy. My question is that are security aspects considered in this hierarchy? Security aspect can be integrated in this hierarchy?
Yes, I mean, well, this topology is somehow internal to the domain, so somehow is hardened, is secure. What we would like to prevent is to reveal sensitive information. As for instance, I commented in the PIDs. The PIDs provide an identifier, but it's quite simple from that identifier to derive the loopback of the routers. So we need somehow to hide that information. When the application is internal, it's not a major problem, but with the idea of exposing this information to external parties could be for sure sensible information. So that would be one aspect. That would be some other aspects to cover in security. So yeah, probably it's a matter to start working on and trying to identify points of for making ALTO more secure and more robust.
In Fujitsu Research, thank you for your answer. In Fujitsu Research of Europe, we are interested in working on trust-related aspect. I think there is some areas where we at least focus on the sharing of different information between different layers. I think that there is definitely something that we can do in that regard.
Perfect.
Thank you very much.
Thank you.
Let's catch up later on, I guess.
Sure.
Thank you.
Thank you.
Okay, I think we can move on. Yeah. Jody.
Okay, yeah, Jerry Rush from Qualcomm. Yeah, so I'm going to be, this is a collaborative work, and Kai, Jens, and myself are going to be doing this presentation. I'm just going to start off. We're going to be talking about a few deployments that are taking place on Alto and some of the science networks in Europe and the US. So next, thanks. Yeah, I'll skip this one. So yeah, the context, this is two things. One is the OpenAlto, the source code base that's been developed as part of the OpenAlto project. It's an open source implementation and platform with an MIT license. It's available on GitHub. The other development is the openalto.org domain. It's a running instance of the deployment of OpenAlto, providing network information in the context of science networks, like I mentioned, such as LHC1, LHCOPN, CERN, ESNet, and NRP, and so on. We'll talk about these deployments in this conversation. And yeah, it's available under this domain. Next. Yeah, this is just a snapshot of one instantiation here of a network that where we're deploying OpenAlto. This illustrates different regions of where the network is running: Asia, Americas, and Europe. This is in particular the LHC1 network that's connecting the experiments at CERN in Geneva, and basically dedicated to move these massive data sets. We're talking about petabytes of information that come from the LHC collider in Geneva. Every experiment, these experiments generating these massive data sets that then need to be transferred to scientists in other regions of the world, whether it's in the US or Asia or anywhere. So yeah, just to get an idea. Next. Yeah, this is the specific architecture that's been running on these science networks, specifically in the CERN network. At the bottom, so this is sort of a layering view. At the bottom, then we have the visibility component, which is implemented using OpenAlto, that's deployed and sort of monitoring the network and providing then the maps, basically. These maps then are fed into the next layer, which is what's called TCN plus FTS, and then the transport control network and the file transfer system. FTS is science networks terminology or technology, which basically schedules data transfers. By looking at paths in the network and finding the right way to actually transfer the data from one point A to point B. We'll talk a little bit more about this as well. And then above this layer, then there is the RUSIO, the Alto-RUSIO integration, which does the orchestration. And this is what the user interfaces with. So for instance, when a scientist or needs to share data with another scientist, then it would actually go into the RUSIO interface and say, please transfer this data set, or please give me access to this data set. And then the transfer would actually get scheduled from that request, goes into the next layer, the TCN FTS, who actually then based on the network visibility, that makes these decisions on where to access data from, and also which path to select, and so on. So it's an optimization problem where Alto is helping bring more visibility to make these decisions in a more informed manner. Next, and this is the architecture. You can see here the overall picture here, that the gray boxes are components that we already had before IETF 114 actually. The green are components that we now have, that as of IETF 115, and in blue components to be developed. But this the way to look at this is the various sources of information that we're pulling from. So, and we organize them in 3 blocks or 3 classes. On the left side, control plane; in the middle, data plane control; and then data plane data. On the control plane, basically it's pulling information from the control plane. The adjacent metrics, subnets, the BGP input, from and then generation of the FIP. And so from here, then DDF reconstructing the topology, the paths, and so on, and creating the network map and the cost map. Another path, another source of information is that the data plane control, which is control information, but we pull it from the devices, from the data plane. So this specifically looking glass, that's the running deployment right now in green, and P4 as a future development in blue. And then, yeah, this leads to also another way to access the FIP. And then on the right side, data plane data. This actually gets the information from the data plane, from the actual sampling packets. So technologies like NetFlow, SFlow, Persona, ICMP. And this is an integration with Gradient Graph, which is running one of the deployments. So actually, the development of a plugin or an OpenAlto plugin that actually gets this data from G2, and G2 actually gets it from the NetFlow, SFlow, ICMP, and so on. And then there's this other component that's being developed also by Jensen and Kai, the equivalent, and Lauren and others, and the team. The equivalent class, which is something that, because in this data plane data mode, we're actually getting the information from the data plane. The actual running flows on the network. You don't have visibility of a path that is actually not active. And so here there's this notion of building an equivalent class, because we still want to figure out those paths. And so create a mapping between creating these classes where if you make a query that acts on a path that actually doesn't exist, that is not active right now, that you can still resolve that path. We'll talk about equivalent classes also in a few slides from now. Next. I'm actually going to turn it to Kai. Yep.
Yep. Thank you, Jerry.
Cool.
Okay, so here is basically an overview of our deployment. So right now we have like 3 deployments. So the first 2 deployments are mostly based on our server deployment efforts. So the first one is to deploy our server inside CERN, and right now it is already up and running in a server inside the CERN internal network, which unfortunately is not accessible from the internet. But then we also have a public mirror hosted at openauto.org. So people can use this server to basically get the information that we provide to the CERN, provided in the CERN deployment. And in this server, we basically implemented the RC7285 and also RC9275. And then the second deployment is also running in the NRP platform. And I believe that hostname is access. It has open access in the internet. But we also have another public mirror hosted at openauto.org. And we have implemented RC7285 and also RC7240, basically the unified property map document. And the last deployment is some update from the client side, because we're not only developing the auto servers for the LHC1 use case, we are also developing some applications that can leverage the visibility information. So next slide, please. And in the next few slides, we basically give some details about all these deployment efforts. And the first one is CERN deployment update, and we're basically fetching information from the quick database, which provides the map, the IP addresses which we are interested of, because in the LHC1 network, it does not actually use every IP address in the whole internet. So it only has some IP prefixes between what they call sites, basically like college, universities, and also science institutions. And then we basically pull this information to help create the IP prefix that we are interested of. And then we also use LHC1 looking glass server to provide as a data source to get information about like ASPath and also the next hop router information. So next slide, please. Next slide, please. And in this slide, basically gives a detailed way of how we actually pull information from the looking glass. And then with the looking glass server, the CERN with a certain looking glass server, we actually can get a routing table on one of the border routers, and then we fetch this information from the looking glass interfaces, and then we parse the data and extract the information that we're interested in. For example, from the routing table on the left side, we can actually extract, for example, the destination IP prefix, and also what is the AS for that prefix, and also what the next hop for the prefix. And using this information, we'll be able to construct the path vectors for the between the CERN between the source IP addresses in CERN and to the destinations in other LHC1 sites. Next slide, please. And here's some examples of, for example, when we make the query to the CERN looking glass server, to the CERN auto server, and it basically respond with the ECS service with the passive vector extension, which includes the next hop information and also AS which is encapsulated as ANE. And on the bottom, basically, it gives an example of how we actually make the plugin to be configurable, where we can specify, for example, what is a backend agent class, which will be responsible to fetch information, and then some parameters that are specific to the agent. Okay, next slide, please. And our second deployment effort is to deployment auto in the NRP platform. And with the NRP platform, we're actually leveraging the current deployment of the gradient graph, and then we are making G2 as some kind of interface between the raw information that is collected at NRP and the auto server. And also we get information from the NRP net stage. Basically, it's it will provide some information about the NRP platform devices and so on. And then with the G2 as a interface, we can actually get information about like link capacity and link delay in the overlay network. So next slide, please. And here is an illustration of how we actually collect information from G2. And basically, G2 provides a snapshot of the information that it collects from the underlying services like SFlow and other tools. And then we basically identify the active flows from the G2 snapshot, and then we map them into like equivalent classes so that we can infer information about flows that are not running currently. And then basically we use that information to create the ANE path. And then what is not illustrated here is actually the G2 snapshot also contains the topology information, and then we can use the links. For example, here the links has an ID 1070, and then we can use that ID to query the topology data and get information about the link. Next slide, please. And here is also an example of the queries and what responses it can receive from the NRP auto server. And on the bottom, we also give examples of how we configure the backend. And then for the NRP case, since we are actually using the equivalent classes to map the sampling results to like prefix data. So on the right hand side, we also give an example of how right now we are configuring the equivalent classes. So next slide, please. Okay, and the last is some update about the Lucio integration update. So in IETF113, we actually added an option to store replicas in Lucio based on a single auto routing cost. And in IETF115, we are extending the capability of this replica sorting and filtering using multiple auto resources. And right now we're actually using two types of information. The first is about the entities. But basically we can query we can do the replica sorting and filtering based on, for example, the geolocation about the replicas, and also the distance between the replica and the place where the which issues the downloading request. And to support the Lucio integration use case, we actually we are using an additional data source, basically the Maxmind Geo IP database. So next slide, please. And here is an illustration of what we are extending in Lucio. Basically, we are using what is called an auto sorting expression, which is basically gives a simpler syntax which can be used by the clients to query the auto, and which will be translated into the auto request in the underlay. And basically, that will help us simplify the development of the client side. So next slide, please. And here is basically an example of the auto sorting expression. Right now, we is actually a circle-like language, and it has two components. The first component is the statement after the by keyword, which specifies, for example, what are the cost metrics that we use to sort the replicas. And then there's also the where statement, which specifies some filtering conditions about the replicas. And also we develop syntax for basically using the BNF format to express the sorting expressions. So next slide, please. And here are some examples of how we implement the Lucio integration. And on the left-hand side, basically, we show how we can configure some metrics that can be used in the sorting expression. And each metric will be configured to, for example, where should the client fetch the information, for example, the auto resource where the client will be getting the information from, and how to parse the raw auto information into the metrics that can be used in the sorting expression. And then on the right hand side, basically, on the left hand side, we basically give two examples. The first is AS hopcount. Basically, it will be extracted from the resource ID called CERN path vector, and then it will be extracted from the AS path property of the ANEs. And because ANE is actually a list of elements, then we will also need to specify how to map this property into a value, and then how to aggregate those values. And also, so on the we also have another cost called delay, one-way delay. And then the one-way delay, because it's fetched from a cost map, so we don't have to specify how to aggregate the results. And then on the right-hand side, we basically give an example of the sorting expression, and on the bottom, we give the results where we sort the replicas using this auto sorting expression. So next slide, please. And about the future deployment plans, so for the 3 deployments, about the LHC1 deployment, so right now, as George shown in the beginning, LHC1 network actually has multiple domains, and so right now we are only deploying in the CERN network, and so the next step is to extend the deployment to multiple domains and provide the multi-domain endpoint call service. And we expect to finish this before IETF116. And for the NRP and G2 deployment, so right now we are actually only using the S-flow data through the G2 service. And so the next step is to bring a further integration with G2 and provide the flow prediction service. And one of the maybe a low-hanging fruit is to expose like fair share as a cost between IP addresses, and also we would try to expose the bottleneck structure as well. And for the Lucio and FTS integration, so right now we are so what we showed earlier is to running in the basically our Docker environment. So next step is to finalize the unified replica sorting feature and send the pull request to the Lucio. And we are also developing an auto assist FTS scheduler, which would use the auto information to achieve like resource control in the science networks. And all these deployments should be. Yeah, sure. Yeah, I know. We only have 1 minute. So next slide, please. So during the process, we also identify some problems that might be, and also we had some experiences trying to tackle these problems, and basically we had some slides describing the issues and also some potential solutions to those problems. Maybe Chin, can you quickly scan through all these pages, and then we can arrive at the last one, basically the feedback to the working group.
So, Kai, you want to take a question? So I just want to, have a question about. So you mentioned for NIP CERN, actually there's some configuration. How this NIP configuration or user configuration relate to the auto OM?
So maybe can you go to the, I think the second last slide? Basically, there's a feedback to the working group page.
So which page? That's the one.
Next page. Before the thanks page. Yep. And so during the process, we, for example, identify like issues such as data conflicts, and then we propose that maybe the prioritization of data sources as a way to resolve conflicts between data sources could be a feature of OAM. And also, we use equivalent classes to specify, for example, what we call the atomic query spaces. So basically, we're wondering whether these should be considered as part of the OAM document, or maybe they are actually out of scope. And also about the extensions to the protocols. One of the problems we identify is that using source and destination IP addresses is not sufficient to support like cross-domain scenarios where source IP address could enter a network from multiple places, but with some, for example, constraints from the upstream ASS, it might be the downstream AS might be able to resolve this issue and determine whether which is the ingress port that the source the traffic actually goes into the network. So I think and also in the NRP case, because the flows the path for the flows can be established on demand, so there might be a need to enable some flow level queries. And yeah, and basically that's unfortunately we don't have time to explain what are the problems and how we handle them. So maybe we can bring the discussion offline to the main list.
Okay, that sounds reasonable. So Jason, do you want to have anything to add here?
Comments about, yeah, just some quick comments about the OM part. So far the OpenAuto implementation, we don't use the YAML model to do the OM configuration, but we have some different formats to handle this. They also include the server setup, the algorithm part, and the data source configuration, and some information resource creation configurations. And so right now we are writing parsers to transform the YAML to their own current configuration. So that's we target to have the fully implemented by the next IETF.
Okay, thanks, Jason. So maybe next. Oh, Rachel, do you have comments here?
I do want to give a very quick comment. One of the main quite different use cases right now we're doing, of course, is auto TCN, right? You probably saw the title we just presenting in the morning. We presented at CERN a couple of weeks ago. We presented at the GRP. So for that one, it's quite a different use case. The main integration is we're modifying the FTS controller. FTS is the main scheduling engine which moves like a EB, exabytes of data, so therefore a really huge amount of data moving around. The one main issue we encountered over there is right now in all the implementation we have right now, they are essentially a single control cluster a cluster will typically have around 6 servers and so on. So actually, right now, a lot of discussions push back. Well, not push back. A lot of discussions coming back from CERN, from all the discussions and so on is eventually to really achieve full goal, we should really be able to do orchestration among all these essential servers. So basically, one FTS controller would have one auto client embedded into it, and eventually right now, for example, right now I think there are around 14 instances running globally. So therefore, we need the auto client to essentially do the integration. So therefore, we really need some way of auto server or client, some kind of aggregation to really be able to do global coordination. So therefore, that's really a very important part of efforts. Probably can get input into OEM as well, because I believe Martin mentioned about servers to server use cases. This is actually one of the server client use cases, or maybe essentially everyone become peer-to-peer to really pull information from all the clusters. That seems to be a major issue, but we don't have full understanding about how it really works yet, because right now we're focusing mostly just get this single domain fully functional.
I think we need to move on. Actually, thanks
sure.
for that.
I'll shut up.
Very useful. Yeah.
Should I start? Hello again. I will comment some few updates on the draft about the usage of ALTO for determining the service edge. So next slide, please. So the motivation, as a reminder, is essentially the fact that we will have multiple compute environments connected across the network. So the idea here would be to leverage on ALTO for taking decision on what data center, what compute environment use for instantiation of applications, functions, and so. But considering both at the same time, the information coming from the compute side plus the information coming from the network. So the topological information enriched with some metrics that could help to take the more optimal decision, for instance, in terms of latency, bandwidth, and so. Next, please. So the updates from latest version, we have refined the text in sections 3 and 4. We have added some clarification statement in section 3 about the fact that ALTO nowadays actually, or currently, does not allow an edge server or an entity, let's say, be represented as an entity in both domains. So we are talking about the compute domain and the network domain. So yeah, we identify that point. And also we have elaborated a little more the text in section 4, and we have provided some detailed examples for retrieving information when these kind of servers or these kind of computer facilities are part of IPv4 and ANA domains. So next, please. So this is an example of the new content this reflects the new content now in the draft. So here we describe how an edge server could be part of the IPv4 and ANA domains. So essentially we play with different identifiers in one domain and another domain, and yeah, we try to relate to both domains. Having some hooks, let's say, that later on could help us to reconcile the information in both sides. Here, for sure, we need to think more on this. By now, we are providing the details of the host. Something to be considered maybe would be, instead of providing the detail of the host, maybe providing the detail of the site, grouping somehow the information. All of this, we need more work on that to understand what could be the kind of information that we could retrieve from the cloud managers, for instance. So to understand well, what is the kind of information that we could take from things like Kubernetes, OpenStack, and so on and so forth. Next, please. We also added an example of filter property map. Here, the entities are reflected as ANEs. So describing in this example, the project that we are following is to consider this idea of quotas or bundles of resources. So having X CPUs, Y amount of storage, and Z amount of disk, and so. So this is why we are categorizing on a small, medium, large. So the usual way for some of the hyperscalers at the time of offering the compute capabilities. So as said, we are describing these as ANAs. We are also presenting them as bundle, and we are characterizing the examples with properties like type of quota or type of bundle, plus CPU, RAM, and disk. We name these instances as flavors, quotas, or instances, and essentially, we discovered that there were some typos on the JSON that we included in the example, so we will fix this in the next version. Next, please. So as next steps, we want to improve the discussion and the interaction with the cloud managers. As said, somehow we have now something generic, so we need to understand well what could be the kind of information that could be retrieved by most common cloud managers existing today or being deployed today, just to ensure that to assess that the approach that we are taking is correct in that respect. We would like to collect comments and feedback from the working group. And also, what the next step will be to keep working on this, to maybe serve as input for a charter discussion in the future. So that's all from my side. Thank you.
Thanks, Luis. Actually, just want to mention there's another draft at the end to talk about a database open source service. So maybe have some, overlap and have some discussion at the end.
Sure.
Okay, let's move on. The next is a movie for network-aware application from Yuhan. He will join remotely to present remotely. So Yuhan.
Hello, can you hear me now?
Okay. Yuhan.
Okay, thank you. Thanks you. Hello, everybody. This is Yuhan from Kansas. Okay.
Your audio get break. Can you?
Sorry. Okay. Okay, can you hear me now?
Yeah, go ahead.
So I will give an introduction for movie for network application. So actually, I think it's rather interesting minimal topic.
Sorry, we are still having troubles to hear you well. So what we can do is that if you can just fix that, we can swap to the next presentation and then come back to you. So please fix it and then, yeah.
Thank you for doing that. So,
Okay, let's move to Jody's presentation.
Okay, so this is a new draft. It was actually presented more in depth actually yesterday during the PAN-RG session. So I'll refer you to that presentation from yesterday, where we explained the details. The context of this draft is bottleneck structures, and we go one level sort of deeper, and we talk about how to compute bottleneck structures under partial information when you have an AS that doesn't know about the information from another AS, and you still try to compute the bottleneck structure. So we think that this conversation is more at the research group level. That's why we sort of move into PAN-RG and considering maybe other RGs. But because bottleneck structures have also been discussed in Alto, and actually the idea that just like we have a network map and we have a cost map, we could also have a bottleneck structure map, which is a compact and efficient way to represent the state of the network and be able to sort of know available bandwidth on a pad and so on. Then we also have a small here conversation about this draft. So of course, bottleneck structures are not in the charter, but that's part of the conversation. Try to socialize the idea, etc. So I want to move on to next. And I'm going to actually skip through. So let's just skip, go through, yeah. Okay, so we've discussed bottleneck structures in 113, so I'm not going to go through that again. But basically, given a network, you want to go next. Yeah. So from a given network, you can compute the bottleneck structure. So that's you can find that in the SIGCOMM paper. So, and then we're not going to go through that. But this assumes that you have full knowledge of the network. Now, what happens when that's not true, when you have partial information? So you're going to click on next. One instance of the problem of partial information is the problem that we face in the internet, where you have multiple ASs. So AS1 doesn't know about the information about AS2 and vice versa. So you don't know about flow information on the other AS. You don't know about topology information. You only know information about your domain, right? So the question is, how do we compute the bottleneck structure under scenarios like this? And so if you want to go next, thanks. And so if AS1 tries to compute its own bottleneck structure just using the information that it knows of, it's going to find this bottleneck structure. And clearly, this is incorrect. If you look at this bottleneck structure here, it's not the subgraph, which should be this region here. This is the global knowledge, the global solution. If you click on next, if AS2 actually tries to find the bottleneck structure just using local information, actually it's going to get it right in this example, but just because it got lucky, because there is this sort of math property that says that if all the paths are bottleneck that I'm seeing are bottleneck in my AS, then I'm actually going to find the right bottleneck structure. So in this case, that's what's happening here, but it just got lucky. So the point is that they must, in order for both ASs to be able to compute the bottleneck structure correctly, there's some information that needs to be shared between ASs. So, now the question is, what is the minimum information that they can share in order to converge to finding the right global bottleneck structure without sharing the full topology, without sharing full information, which is of course very sensitive. And that's sort of what this draft discusses, the solution, and proposes. There's actually a distributed algorithm that just works at the border level, and three properties. Convergence, sharing one metric per path is enough to ensure convergence to the correct bottleneck substructure. So that's one of the results. Scalability focuses on building the path gradient graph. So in the previous draft, we discussed that there are different versions of the bottleneck structure. There's a flow gradient graph and the path gradient graph. The path gradient graph is way more scalable because it works at the path level. So you may only have hundreds of paths as opposed to millions of flows, right? So this distributed border protocol works at the path level, which makes it way more scalable in that sense. So so it requires only per path state. And then privacy, does not require sharing your network information. All you need to share is a path metric and a scalar, basically. So we can go next. And I'm actually going to skip the distributed protocol. So move on next. Yeah, next. And just at the very high level, how does this work? So again, we have a network that actually has two ASs. So we go next. And again, we don't have to understand anything. It's just the intuition. So AS2 is trying to find the bottleneck structure. At iteration 1, it believes that this is the state of the network, the bottleneck structure. This is incorrect. AS1 does the same. It does its own local computation. It finds this bottleneck structure. It gets lucky, and actually, this is correct. But the point is that there's this notion of path metric dictionary. Each one is tracking a path metric dictionary, and what they do, they share the PMDs. And if they share the PMDs, which is only one metric per path that they need to share, then they share this one has converged, so it's good. But then the next iteration, thanks. Now with this PMD information that they have exchanged as neighbor ASs, then now AS2 can actually converge. And if you click on next, thanks. Now you can see, you can compare that this subgraph is correct basically now, right? And this is responds to this portion of the bottleneck structure. So this is a mechanism for both to converge to the correct global bottleneck structure without sharing sensitive information. You can see sort of the intuition behind this, what this is doing, that AS2 converges to the right bottleneck structure. It cannot, there's the notion of virtual nodes. It doesn't know what this is. Actually, V1 and V2, it has a path metric also, but V1 and V2, in fact, happen to be AS1. But AS2 doesn't know what that is because it doesn't have any visibility. But that's sort of how it models. And the bottom line is that with this information, now you can actually do traffic engineering decisions without exposing or having full knowledge of the neighboring ASs. Okay, so next. At a very high level, how does this would work? Basically, so you have ASs, each one is computing the bottleneck substructure locally, and then you have these messages being shared, the path metric announcement packet that's being shared. So they just share the path metric dictionary between neighboring ASs. Okay, and the conversion time of this algorithm is actually logarithmic because it actually converges in the same steps as the bottleneck structure, basically from top to bottom. So from that standpoint, so it has some good scalability properties. Okay, so then next. Yeah, and then so what does this? How do we connect this with Alto? So with Alto, we're discussing whether standardizing bottleneck structures as another way to represent the network. We have network maps, we have cost maps, and then we could also have a representation as an object of the bottleneck structure, right? And so the question is now, but in typical networks, they're multi-domain, so you have multiple autonomous systems. And so each one could have an Alto server, right? And so how do you compute the bottleneck structure in a multi-domain environment? So this would provide a solution, and then the requirements at the very, very high level, just to start the conversation, is requirement one is the capability to compute the bottleneck substructures. This actually is the same requirements as the previous draft. It just says that, well, now we have to have a way to compute the bottleneck structure, basically. And requirement number two is the requirement between two autonomous systems to be able to communicate, or two Alto servers to be able to exchange this path metric dictionary. So this would be sort of a new requirement, as it's been mentioned this morning. There is no server-to-server communication RFC right now for Alto, but this sort of this would be a use case to help that potential conversation about how do Alto servers communicate with each other, what kind of information they could be sharing. The path metric information from the bottleneck structure could be one of the use cases. And I think that's covers this part.
Any question from Flo? Just one quick question for distributed border protocol. How does it relate to the BGP or Auto protocols?
So the question is, where do you implement it, or
how this distributed border protocol is related to the BGP or Auto protocol?
Yeah, so it's similar to BGP. So BGP is an algorithm that the key idea, the core idea is that with local information, you can converge to the global sort of optimal routing, right? Just by sharing some messages between neighbors, basically. So this is the same concept, but in this case, what we're doing is not just topology information. We're also bottleneck structures taking into account traffic engineering information, because it's taking into account the flows that are running on the network, and then it provides this path metric, the capacity. So in terms of implementation, it could be running in parallel to BGP. It could run as part of Alto. It could run separately. That's why we're having this conversation also in the research groups to understand where could this be most suitable, basically.
Okay, thank you. So let's move on to the next presenter, remote presenter. Dongyu, are you there? So.
Okay, I'm here. Can you hear me?
Yeah, we can hear you. Go
okay,
ahead.
Thanks. Okay, respectful colleagues and experts, with great honor and sincerity, and on behalf of our group and DT Corporation, I would like to share our related work and perceptions on service provisioning of the network. And the topic I would like to introduce here today is database-based open resource service, framework use cases, and requirements. As for the previous presentation of determination of service ages, maybe we share similar perceptions. Maybe we can have some discussion after the meeting. Okay, and next slide. And so far, we proposed draft only requirements and framework of DBO that's listed here, which illustrates the background information and pivot perceptions. And our considerations begin with the challenges of the current network. And next slide, please. Okay, so with the rapid development and comprehensive utilization of cloud computing and mobile internet, the cloud becomes a popular and major platform for various enterprises and government departments to host data and applications. Data explosion and massive access to the cloud have been proved to be an inevitable inclination, resulting in accelerating growth of traffic traversing through the network domain. And as depicted in this figure, the network domain from Ningxia to Guizhou is divided into several sections and multiple routing paths The network infrastructure in different sections may vary from one to another, which results in distinctions of network capabilities. Applications may acquire diversified requirements of latency, bandwidth, or flexible and comprehensive demands, like here, application A, B, and C. Ideally, traffic of distinct applications from PE near Ningxia to another PE near Guizhou should be steered respectively into paths shown here in different colors. But in conventional networks, with the details including path distances and section bandwidth and the network domain concealed, capabilities of the network remain invisible. So differentiated services are not provided. Applications with various requirements cannot be distinguished and served customarily. A latency-sensitive application here could misunderstand that the bottleneck of the traffic is the restricted bandwidth from Ningxia to Gansu. However, in fact, the difference in different paths through Sichuan and Ningxia is over 200 kilometers, which results in apparent delay. So fine granularity services of the network are not explored and deployed here. And next slide, please. What's more, in this occasion, due to the bandwidth restrictions in the Shanxi, Hebei, and Hebei Liaoning sections, the bandwidth of the overall path is confined, and the sectional resources are wasted to some extent, and the overall utilization is relatively low. And to support that, the resource utilization proved to be relatively low for about 30% to 50% at present in China. And with ideal conditions, suppose here some sections could be utilized and the traffic could be steered intellectually in the black line. And next slide, please. So to sum up, fine granularity network services provisioning and network resources utilization enhancements are urgently required today. And next slide. So besides bandwidth, for instance, Dragon's network has also been endowed with various other capabilities, including deterministic quality network slicing endogenous security, which can be delivered as services. Referring to SaaS, DBONet framework is proposed, aiming to practice the concept of NaaS, namely network as a service. And with the services reserved, applications, cloud, terminal, and CPE could subscribe to corresponding customized network services. And next slide, please. In the framework of DBONet, the network controller collects the running status of the network and abstracts network functions by extracting key attributes. And a distributed database is introduced, which sustains strong consistency, and a typical subpub mechanism is applied. Capabilities can be abstracted in a key value scheme, and a standard schema template file is utilized for descriptions. The cloud controller or a super architecture further subscribes the updated information of services with a watch mechanism, which enhances the efficiency of information advertisement. And with the knowledge of network capabilities, path calculation can be performed and services can be re-orchestrated and bound with specific policies. And also, with database clients watching updated information, path degradation, for instance, can be reflected and learned. Traffic can be further redirected. And next slide, please. To illustrate the explicit process, we here present a data instance. The network communicates various clouds and multiple applications. Here A, B, C, and D construct part of the physical topology. And path and network resources among them are abstracted in the form of VD-link and VD-link here. They constitute a substitution for original links, and unique logical topologies are perceived from different cloud applications. Here may be seen from Cloud A, data link from A to D includes two paths of segment release, but is observed with only single segment release by cloud B. Resources like bandwidths are also distributed respectively for different virtual links. And as shown below, logic topology is identically, but resources are reserved exclusively. And next slide, please. In particular, to define VD-link and VT-link, the previous one is a virtual version of a physical direct link, which can be identified by local and remote node descriptors, interface addresses, and other parameters of capabilities. And similarly, VT-link represents a virtual tunnel. Taking segment routing over IPv6 as an example, typical attributes include logic ID, node descriptors, maximum reservable link bandwidth binding seed. And to facilitate path calculation, a new logic ID is defined here to identify VT-link or VT-link. It should be globally unique in the network domain as a key. Next slide, please. And here are some similarities and differences here between Auto and DBONus. We share some similarities, but we may focus on different scenarios. And next slide, please. And as for conclusion, more perceptions and drafts are expected in the future, and we are looking forward to promoting our work and to cooperating with working groups and experts who have resonated with the issue. Safety and service affinity issues should also be considered in the future, and that's all about this presentation, and thank you all.
Thanks, Dongyu. So we have two people in the queue. So the first one, Li Weima. Can you speak?
Hello, can you hear me?
Yes. Go ahead.
Oh, hello. Yeah, I'm Li Weima. I really thanks for the presentation. It's very wonderful. And I have two comments. The first one is about the comparison with APN. APN, which is application aware networking. I think the use case in this proposal may be similar to the user case in APN, and it makes sense to analyze what are the difference between them. And the second question is about computing awareness network, which is called CAN. Currently, CAN also has the use case for the integration of the cloud and the network. Could you mind analyze the difference between them? Thank you.
Okay, thanks for the question. And let me answer the questions. So as for APN or CAN, CAN, our perceptions may share the similar or identical use cases to solve the future scenario of the convergence of the network and the cloud. But we have some different solutions. Both APN or CAN, they focus on the layer 3, that is the network layer. They need to extra extension headers to bring about the identifiers of applications into network domain, and the forwarding behavior could be instructed by some mapping relationships. But here in our DBONus, the network capabilities are exploited and seen from the maybe a super orchestrator, and our focus is about the path calculation, and we do not need some extra extension headers in the network domain. So it's all about the questions.
Okay, Dongyu, try to make your answer short. So for the other people, yeah, please make your answer question also short. Yeah, thank you.
Yes. This is Luis Contreras from Telefónica. One question: you are characterizing the internals of the data center, and you are including in as a metric the delay. But the delay in the internals of the data center, as you reflected, is in terms of microseconds. So taking these microseconds in the overall computation of the delay introduced by the network, that will be in order of milliseconds, probably is not relevant. So I would like to, just the question is if you consider relevant this delay metric in the internal of the data center.
Okay, here just will make some the prototype of the session network capabilities, taking latency delay into our consideration. And as for practical scenarios, maybe it will be a good question or something we need to configure it in the future. And I'd like to have some discussions maybe after the meeting.
Okay, thanks, Dongyu. So let's move on for the next presenter, Yuhang. So probably we need to cut the time actually.
Hello, Qing. Can you hear me now?
Yeah, we can hear you.
Okay.
Great.
Yeah.
5 minutes.
Okay. I think I can go directly to the update part. So, yeah. So, okay. So next slide, please. Next slide. So yes, we have in the movie, and we have some standardization considerations. And in 3GPP, and we have released 17 5G AS, which focus on the skills enhancements for interactive services, including cloud gaming, XR, and so on. And in release 18, and there is an item which is called XRM. It focuses on strengthening the interaction and collaborations between applications and networks by improving the ability of the network information exposure, especially for XR and multimedia services. Also in 5G AA, and the movie can also have a use case which is called predictive queues, and it utilizes the network information exposure to predict the future network changes to the application layer in order to be prepared for such changes and make adaptations in application layer to improve the QE of the users. And in EDSI, RNS has proposed to expose physical layer, but it is just for the MEC case. So, and the movie is not restricted to it. So next slide, please. So in this slide, we have some substantial updates based on some comments from MED and other experts during the 114 IETF meeting. And we have some further clarifications, and for example, and we added some motivations for predicting the network instead of responsiveness of the memory. And we add some related work that is relevant to 3GPP and 5G, which can be utilized by movie framework. So we can. So I think the main point here I would like to illustrate is that we give a framework of the convergence of 5G network architecture and IETF-ALTO. So I think the main point is that the EF can be acted as that. I think the main point is that the auto plant can be acted as EF or the functional model of the EF through the implementation of some implementations. And so next slide please. And so I think so here here you can see the EF or auto client can receive some network information through the movie by step 1 and step 2, and then the auto client can also receive some auto information from the auto server through the auto server discovery. So the auto client can support the application adaptation using this exposed information. So next slide please. So we can conclude one point that the movie architecture has been proposed and refined in several versions, and the architecture of auto and movie framework is proposed in this version. So I would like to ask if there are any suggestions to this work, or how to incorporate this work to the charter item. So that's all. Thank you.
So thanks for your presentation. Actually, this is not a new draft actually. So I'm just one quick question is, do you have implementation for this movie? Second one is, how do you collaborate with 3GPP? Any feedback from 3GPP?
Yeah, actually, we already have some analysis on this topic. Just for example, how EF or AF related to this work. I think the main point is that we can. So we can have more discussion if this work can be, if this work can be incorporated to the charter item. So
okay, I think so we can wrap up now actually, so we can take it to the list and see how we can move forward. So I think probably we at the end of the session, and thank for all the participants actually, especially who actually attend in person. And any last comments?
Thank you. Ayub Missus from Fujitsu, Research of Europe. I basically have like a quick comment. I had the chance to discuss with the different work group members, and I found this topic very, very interesting to our work in Fujitsu. We're trying to focus on, again, on network trust. And we already, I think, found some areas where we can collaborate. And hopefully after this meeting, we'll try to join the discussion and maybe find like specific use cases where we can implement network trust and help move Alto in the future. Thank you very much.
Yeah, thank you for your interest. Actually, I suggest you write email to the list, summarize what is your focus, and to get more feedback, and so we can see how to move forward. Definitely, for multi-domain setting, actually security issue is a bigger issue, so we need to have more discussion on this.
Just to give you a quick heads up, in a couple of, maybe a week or two, we do have a white paper coming. Once we have published that white paper, I will share it with the group. So this will better explain our interest in this topic and how we can move together. And hopefully by Yokohama meeting, because Fujitsu is also participating in the organization there. So we'll try to prepare something for that meeting.
Okay,
thank you.
Okay. So we can wrap up actually. So see you in Yokohama. Yeah, thank you. Yeah, thank you for
Figures